Hey guys, today we're going to be looking at the substitution method of solving systems of equations. So as you can see, the substitution method is a method of solving systems of equations by substituting equations within another. So there are steps to do this. Step 1, you're going to have to solve one of the equations for either x or y. Step 2, you're going to substitute this expression into the other equation and solve for the opposite variable. Step 3, substitute your answer into the revised equation from step 1 and solve for the other variable. I know that's just a lot of words right now, but once we get into it, it's going to make a lot of sense. So let's go ahead and look at our first example here. Alrighty, so here's our first example. And we're really lucky with this first example because we have two equations that are already solved for y. And that's our ultimate goal. Let me just make this a little bit bigger so you can definitely see it. Alrighty. So here's our examples. So our first step told us to solve one of our equations for a variable. Well, as you can see, we have two solved equations for variable. Y equals, see this one's solved for y, as is this one. So if y equals this, 4x minus 1, then what I'm gonna do is I'm gonna substitute it, like our step said, into the other equation for that same variable. So I'm gonna have, instead of the y over here, I'm gonna substitute in 4x minus 1 equals, that's coming right from there, the 2x minus 5. So I substituted the expression that y equals into y for the other equation. Looks a little bit different here, but what you'll see here is more likely what you're gonna see. So pretty much you just set these equal to each other. All right, now we have to solve for x. So I'm gonna subtract 2x on both sides. Drop that down. 4 minus 2 gives me 2x. I'm going to bring everything else I have down. Next, I'm going to get rid of this 1. So now 2x equals negative 4. When I divide by 2 on both sides, x is going to equal negative 2. And well, that gives me half of my solution because I know that a solution to a system of linear equations is an ordered pair. And so up here, I'm going to put negative 2 in for my x, and I still have to solve for my y. So for my next step, it told me to take whatever my solution was for that variable and substitute it in to one of the first two equations. So it doesn't really matter which one I choose. I'm just going to do this top one. So I have y equals 4 and not the x. I'm going to substitute what I solved for the x in here. So there's that negative 2 right there, and then minus 1. Now we just have to simplify. 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. So my final answer is negative 2, negative 9. Not too bad. That one might have been a little bit confusing, but that's okay. Let's look at the next one and hopefully that'll help a little bit. So I noticed I have two equations here. One of them is solved for a variable, and that's this first one. See how the y is by itself? So I'm going to take whatever it equals, the 6x, and I'm going to substitute it in for y in the other equation. So I'm going to put this in for that y. So I have 2x plus 3 instead of my y. I'm going to substitute in that expression, which is 6x, and I'm going to continue here with this one. All right, let's distribute. I'm going to drop down my 2x first. 3 times 6x is going to give me 18x. I've got some like terms, so I'm going to combine those. 20x equals negative 20. When I divide by 20 on both sides, x equals negative 1. All right, that gives me half of my answer. I'm going to put that up here. I'm going to need to substitute in negative 1 for an x for either of my two equations and solve for the y. I'm definitely going to plug it in up here just because it looks like it's going to be a lot easier for me. So up here I have y equals 6 1/2 And instead of my x, I know my x is equal to -1, so I'm gonna substitute that in right there. 6 times -1 is -6, and there's my final answer. -1, -6. All right, I feel like we're getting the hang of it. Let's continue. Let's check out these next two examples here. All right. All right. Number 3. Okay. So I'm going to ask myself, is this equation solved for a letter? Is there a letter by itself and then an equal sign, blah, blah, blah? Yes. Is this one? No. Since this one is already solved for a variable, I'm going to take this expression and substitute that in for the y in the other equation. So that's going to go in right there. So I have 3x plus 8 times this whole expression, which is x plus 9. Then I'm going to continue with the rest of that equation, equals -5. All right, let's distribute. 8 times x gives me 8x. 8 times 9 gives me 72. I'm going to bring down my 3x here. All right, we have some like terms. 3 and 8x give me 11x. I'll bring down everything else. I want to get this x by itself, so I'm going to have to subtract 72 on both sides. 11x equals -77. So when I divide by 11, x is going to equal -7. That's half my answer. We solve for our x, so we're going to take this value and plug it back in and solve for the y. I'm going to go back up to this first equation, but you can plug it into either and solve. So I have y equals, instead of my x, I'm going to substitute in -7 and then plus 9. -7 plus 9 is going to give me 2. So my ordered pair is -7, 2. All right, I like this next one because it's a little bit different. Instead of having one of the equations solved for y, we have one of the equations solved for x. See how x is by itself. So since it's by itself, I don't have to solve for a variable first. I'm going to take this expression and I'm going to plug that in for the x in the other equation. Since I know this is what x equals, I'm going to substitute this in for the x. So let's rewrite this bottom equation, but instead of my x, I'm going to put in 4y plus 7. I'm going to continue with this expression, with this equation. So I have -6y equals 12. Now we can distribute. 4 times 2 is going to give me 8y. 2 times 7 is going to give me 14. Bring down everything else. I have some like terms here. I have a positive 8y, a -6y. If I combine the two, I'll have 2y plus 14 equals 12. Got to get rid of that 14. I'm going to subtract on both sides, leaving me 2y equals -2. And then if I divide by 2, y is going to equal -1. So in my ordered pair, I know that the y is -1. Now that I have that value, I'm going to go back to one of my two equations. I'm going to use the top one. I'm going to substitute -1 in for the y. So I have x equals 4 times -1, because remember that's where I got that y from, plus 7. 4 times -1 is -4. Well, ahead of myself here. -4 plus 7 is going to give me 3. So my ordered pair is 3, -1. All right, not too bad. Those first 4 examples are not bad there, but what you're going to see on the next page, number 5 through 11, is that they're not going to be solved for a variable. We're going to have to do that extra step first. So let me scroll down here and we can look at those examples. Alrighty. So with substitution, this is really the only part that kind of trips most people up a little bit, is finding which equation is easier to solve for. But I'll kind of give you a hint here. So I see that neither of these two equations is solved for a variable, y equals or x equals. But what I do notice is that that y is by itself. So the only thing I'd have to move on that side of the equal sign is the 2x in order to get the y by itself. So I think that that's probably the best bet. So I'm going to rewrite this equation here. That's that top one, and I'm going to solve for y. To get the y by itself on the left, I need to subtract my 2x on both sides. It goes away on the left. I get y equals, I'm going to put the negative 2x first, and then the negative 2 after, because they're not like terms, I cannot combine them. Alrighty. Next, I'm going to look at my other equation. I'm just going to grab a different color here. Now that I've solved for that y, I'm going to take what the y equals, and I'm going to substitute it into the other equation for y. So let me rewrite the second equation, but when I get to that y, I'm going to substitute in this expression. So we have 5x plus 3 times negative 2x minus 2 equals negative 8. So I rewrote this whole equation, except when I got to the y, I replaced it, or I substituted what y equaled. So now let's distribute. I'm going to bring down my 5x. 3 times negative 2x is a negative 6x. 3 times negative 2 is negative 6. I have some like terms. I'm going to combine them. 5 minus 6 gives me negative 1x. Bring down everything else I have. Next step, I need to get rid of that negative 6, so I'm going to add it on both sides. Negative 1x equals negative 2. Now, I'm just going to divide by negative 1, and x is going to equal 2. There's half of my solution. Not too bad. I'm going to go back, take x equals 2, plug that back into one of my top 2 equations, and solve. So I'm going to go right back to this top one, and I'm going to substitute in 2 for my x and solve for my y. So I have 2 times 2 plus y equals negative 2. 2 times 2 is 4. I gotta get rid of that 4, so I'm gonna subtract it on both sides. So y will equal negative 6. So my solution is 2, negative 6. All right, let's keep with that similar mindset. Which one of these equations would be easier to solve for a variable? Well, whenever you see a variable by itself, that's probably where I'd go. So I'm gonna solve for the y in this one. I need to subtract my 2x on both sides of the equal sign and bring down y equals negative 2x plus 9. All right, now that that's solved for, I'm going to take that expression, what y equals, and I'm going to substitute it in for y in my other equation. So let me rewrite this top equation, but I'm going to substitute this in when I get to the y. So I have 2x minus 3 times, this is where I'm going to substitute it in, negative 2x plus 9, let's continue, equals negative 11. Let's distribute this negative 3. First, I'm going to drop down my positive 2x. A negative times a negative would give me a positive 6x. A negative times a positive would give me a negative 27. So far, so good. All right, I'm going to add those two together because they're like terms on the same side. And I get 8x minus 27 equals negative 11. I'm going to add 27 to both sides. 8x equals 16. When I divide by 8 on both sides, x equals 2. All right, I've got half of my problem here. Now I just have to take that value of 2 and plug it back in and solve for my y. So I'm going to use the bottom equation. I'm going to use this one right here. So I'm going to substitute the 2 back in. So I have 2 times 2 plus y equals 9. I know 2 times 2 is 4. I'm going to subtract 4 on both sides, and I get y equals 5. So my order pair for this one is 2, 5. All right, we got a few more to do. Let me scroll down, and then I can erase. Going right through these guys. So on that the first 4 that we did, we already had an equation that was solved for a variable. In these new ones, from 5 on, we had to solve for a variable first. So again, with number 7, I need to solve for a variable first. I'm looking for any variable by itself. I see the x, that's where I'm going right away. I'm going to solve this for x. In order to do that, I need to subtract 5y on both sides. So then x is going to equal negative 5y plus 4. Now that I've solved for that x, I'm going to take this expression and I'm going to substitute it in for x in the second equation. So here's that. 3 times negative 5y plus 4. Then I'm going to continue with the rest of that equation. Plus 15y equals negative 1. Distribute. 3 times negative 5 gives me negative 15y. 3 times 4 gives me a positive 12. And I'm going to bring down 15y equals negative 1. Alrighty, I see some like terms here. I have a negative 15y and a positive 15y, which cancel each other out. So now I have 12 equals negative 1. That's not a true statement. So what this means is that I have no solution. What it would look like if you were graphing this is parallel lines, because they would never intersect. All right, let's look at our next one. Number 8. I hope you can see that that top equation is going to be a little bit easier to solve for a variable because that x is by itself. So I just need to move the 4y to the other side, so I'm going to subtract it on both sides. So now my x equals negative 4y. Now that I've solved for my x, I'm going to take that expression and I'm going to substitute that in for the x in the other equation. So I have 3 times negative 4y plus 2y equals 20. 3 times negative 4 is negative 12y. I have some like terms, negative 12 and a positive 2 gives me negative 10. I'm going to bring that down. And so when I divide both sides by negative 10 to get the y by itself, I'm going to get y equals negative 2. All right, I've got that. Let me plug that back in and solve for my x. I'm going to go back to this top one and have x plus 4 times, well, I know my y is worth negative 2, that's the value, and that's going to equal 0. Well, 4 times negative 2 is negative 8, so x minus 8 equals 0. If I add 8 to both sides, x equals 8. All right, not too bad. Looks like we have 3 more to go. Let's see what those answers might give us. We'll do 9 and 10, and then we'll jump to 11. Alrighty, substitution method. Looking at number 9, I see this bottom equation has the y by itself right here, which means that the only thing I'd have to do to get that y by itself is to subtract the 2x on both sides, leaving me with y equals negative 2x plus 18. Now that I've got that solved for, I'm going to take that and I'm going to substitute in for y in my other equation. So I'm going to have, I'll write this up here, 6x plus 3 times negative 2x plus 18 equals 54. All right, let's distribute. 3 times negative 2x is negative 6x. 3 times 18, I believe, is 54. I'm going to bring down my 6x. Well, I have a positive 64, or I have a positive 6x and a negative 6x. They cancel each other out, leaving me with 54 equals 54. That is a true statement. So that means I have infinitely many solutions. Why do I have infinitely many solutions? Because it's the same line. All right, I like those ones. It makes it easy for us. Let's jump to number 10. All right, I see the x by itself. The only thing I'd have to move is that 3y, so I'm going to do that right away. So now x equals 3y minus 2. Now that I've solved for that x, I'm going to substitute that in for my x in the other equation. So I have 10 times 3y minus 2. Close that back up. I got to continue with that other equation, plus 8y equals negative 20. Let's distribute. Getting 30y minus 20 plus 8y equals negative 20. I see I have some like terms, so I'm going to combine those. We have 38y minus 20 equals negative 20. I'm going to add 20 to both sides, leaving me with, and I'm going to bring it up here, 38y equals 0. If I divide both sides by 38, I know 0 divided by anything is 0. So I have half of my ordered pair so far. Now that I know that the y is 0, I'm going to plug it back into this top equation and solve for my x. So I have x minus 3 times 0 equals negative 2. Well, this is going to give me 0, so x equals negative 2. Negative 2 zeros, my ordered pair. All right, guys, one more. You did a great job. Thanks for tuning in. Last one. Alrighty. It's going to take a little bit more than one step, but I see the y is kind of by itself here. It has a negative 1 there. Let me rewrite that equation so that I can solve for y below. So I'm going to get this guy by itself. I need to subtract my 3x on both sides, leaving me with negative 1y equals negative 3x minus 8. These aren't like terms. I can't combine them. Then I need to divide by negative 1, leaving me with y equals 3x plus 8. Now that I've got that y solved for, I'm going to take that expression and substitute it into my other equation for y. So here we go. We have 5x plus 2 times, instead of the y, it's going to be 3x plus 8. Alrighty, continue right on. Equals 5. We'll distribute here. Let me drop down my 5x first. 2 times 3x gives me a positive 6x. 2 times 8 gives me a positive 16. I've got some like terms here. 5 and 6 together give me 11x. Gotta get rid of the 16, so I'm going to subtract it on both sides. 11x equals negative 11. Divide by 11. and x is gonna equal -1. There's half my answer. Let's plug that -1 back in. I'm gonna plug it into this top one. So we have 3 times -1 minus y equals -8. 3 times -1 is -3. I'm going to add 3 to both sides, giving me -y equals -5. And I know to get the y by itself, I need to divide by -1, so y equals 5. And we're done. Thanks so much, guys, for tuning in. That was substitution method, and we'll see you soon.